Right, so I'm just going to start working on encodings for various conversions. So there are a bunch of different mnemonics for conversions here, and I'll just work on the scalar ones right now and leave the packed ones for another time. When it comes to these conversion instructions, these two here go along with this one here and the other SI one here. So 2SI can all go together because their forms are very similar. Then we've got, for example, this 2SD and this 2SS here are actually very similar, and then these two in the middle are very similar as well. So I can sort of group them like this to write out the tests all at once, and then I'll implement them all at once as well. So to do this, I'll start with this convert SS to SI instruction. So we've got to convert SS to SI, and then the forms that we've got here are basically RM, where the R operand, or the destination operand, is 32 or 64 bits. So for example, we'll do ECX with, let's do XMM0. Then we've got a memory one here as well. Then we need, let's do the 64-bit one. So this is just the same thing, but with R64 instead. Then we've got VEX versions of these, which are the same thing, but with V. And then we've got EVEX versions, which are the same thing again, but this time we can have rounding on here, embedded rounding. So we'll just go and take these and do an embedded rounding test here. And we'll also do high 16 as well, just to make sure that these are definitely tested as EVEX with some more EVEX features. This one is the same as this one up here, so this is actually going to use VEX-encoding instead, because we can't use embedded rounding with a memory operand anyway. So that is that instruction done. Then we can move on to this other SI one here, which is from SD. So this is the same thing, but just a different mnemonic. So we've got convert SS is now convert SD to SI. This one again has rounding, so we'll keep that in there. And then these are the same as the convert with truncation versions as well. So we'll just change this CVT to CVTT. So it's convert with truncation. Then we have, so that takes care of this one, and the truncation versions down here. So now if we do SS to SD, so let's just write this again. So we've got convert SS to SD. And this one just has RM, but we can use op masks, and it's suppress all exceptions here. And VEX and EVEX have 3 operands. So this one is XMM0 with XMM1. And this one can also have memory. Then we've got the VEX version, which has 3 operands. And then we've got the EVEX version, which I won't use the high register for. But instead this one allows for op masks, so we'll use those. And it should allow for suppress all exceptions as well. So that's that one done. And then we've got convert, instead of SS to SD, it's SD to SS. This one allows for rounding instead of suppress all exceptions, so we'll do rounding on this one. And then we've got SI to SS, which is RM. It looks like it's basically the same as one of these up here. So SI to SS, maybe we'll just take this one and put it down here, but the instead of having the operands are flipped around, basically. So we should be able to just take these ones and put them on this side. And these memory ones here, these should actually be, for example, xmem0, and then the memory access should be here. So for this one, we actually need to say, well, let's just change this mnemonic first. This is SI to SS. SI to SS. Then for this one, I'll need to specify that this one is D word and this one is Q word. We'll do D word and Q word again down here. And then this one is obviously going to be, so this has 3 operands for VEX and EVEX. So the VEX and EVEX ones, we'll do xmem1 here, and then this rounding on the end is actually over here. So this is with, this has a potential memory operand on this side. So let's just get rid of that and do memory operand. And I think that should cover all of those instructions. So let's just go to NASM. We'll do the listings again. So this was SSE ASM, and we'll just create the listing for that. Embedded rounding, not possible. So it looks like NASM is actually incorrectly rejecting this. So this is line 87. And this goes on to line 99 as well. So actually, I think it's all of these ones. So those are actually valid. It's just that NASM is not allowing it. Then 109 as well. So this one should also be valid, SS to SI. Let's just check. Yeah, these have embedded rounding. Yeah, SS to SI. Oh no, this one doesn't have SS to SI. I don't think this is the truncated version. So yeah, this one is suppress all exceptions. So let's just see if that works. Suppress all exceptions, and then the SD to SI also has suppress all exceptions. Okay. Well, so that should be valid, but NASM is still rejecting it. Okay, well, so we've got some test cases at least. So let's just go and check this and make sure that the encodings are what I'd expect. So we've got EVEX, VEX, legacy, EVEX, VEX, legacy, EVEX, VEX, legacy. I can't see any EVEX mixed into the wrong places here, so I think that is all okay. So I think maybe now I can just take all of these over to encoder test. And we'll put them all in here. So these are all of the CVT instructions. So we're going to match on some width, and then we've got a bunch of operands to fill in. So before I do that, let's just go and add these ops. So we've got, let's do it below these ones here. So these are going to need to be deduplicated. Okay, that looks like it's correct. Maybe we'll just order them. Or actually, no, we won't order them. We'll just do it in the same way as the test. Then let's just add them to the forms. So we got shuff PD, and we'll put them below here with empty forms. Okay, so now to fill in the test. So basically, all of these are XMM, which we know because SS is going to be a scalar single precision value. So the SI is the ambiguous width here. So I'll basically match on the width that's needed for SI here. So in this case, it would be D word, and in this case, it would be Q word. Then that just repeats down here. So we got D word and Q word. Then for this, we got D word once and then Q word once. So for all of these, we've got CX over here. Then we've got V0, then NA, NA, because these are all just two operand ones. These ones need CX to be a memory access. Oh, actually, these ones are actually going to be CX as the second one with a memory access. And then this one is using high 16 register to force VEX-encoding, and we can't do rounding, or we can do rounding, but it's not possible for me to test the rounding here because NASM is incorrectly rejecting that as like a valid thing to write in assembly. So this one is basically going to be the same thing. But instead of SS, this is now going to be SD. Then it looks like we got the same thing again. But this is the truncated version. So CVT becomes CVTT. And this would allow suppress all exceptions, but again, NASM is incorrectly rejecting that. So we'll just copy these down here. I'll just make sure to implement embedded rounding and suppress all exceptions in my forms table, even if I can't test it, because I know I am encoding it correctly. So now we just need to do some things for this. So this has, the sizes are known in these ones because it's SS to SD, which are always 32-bit and 64-bit. So for this one, we'll just match on X word for all of them. Then we've got V0 and V1. But this one has CX as a memory access, and then we've got three operands here. So this one is NA, NA. This one is also NA, NA. And then this one just has one NA in there. So we've got V1, we've got CX.M with NA. Then we've got, this one is V2. But on V2, we also have SAE. And then NA. And then this one, V1, oh sorry, V0 for both of these actually is using K. So we've got K1 with Z. And then here we've got CX with memory. Then here we've got the same thing again, but this one is not using suppress all exceptions. So this one is just switching around SD with SS. But instead of suppress all exceptions, we've got ER with RN. So that's rounding nearest that implies suppress all exceptions. The rest of it looks like it's the same though, because we already know the sizes. We'll match on X word again. And then this one we got SI, which is the unknown thing, with SS for this particular one. So let's just see. SI to SS. Yeah, so I think this one is going to basically be the same as this. But this one has two rounding versions which weren't in the other ones there. So actually I'll just fill these out manually. So for the SI and for the SI widths for this one is D word. These ones are Q word. And this is just going to repeat down here because this one, NASM, didn't reject the rounding, which is correct. So for these ones, we'll do V16, and then we've got V1, and then we've got CX. We'll do .m with NA. But these two top ones for each of these tests here is actually CX with embedded rounding, RN. Then for these ones, we've got V0, V1, and CX again. But these two here are memory access. And then for these ones, we've got V0 and CX, because these are just two operand cases, where these two here are memory access. Okay, I'll keep the comments in for now, just in case I've mistyped anything. Too few values, 682. So in this one, we've got, for example, we need NA. So this is NA, and then this one down here is NA as well. Okay, embedded rounding can only be applied to vector operands. So where have I got ER that's incorrect here? Yeah, so I think ER is going to need to be allowed on, so if we go to ER and allow it on reg as well. So if it's not any of these, then we'll allow embedded rounding can only be applied to register and vector operands. And I'll probably need to do the same for SAE as well. Because where it can't apply is memory. Because if you apply it to memory, that's setting evex.b, which makes it a broadcast instead. Okay, so now we couldn't match an instruction form. So going to SS to SI, we'll go to the forms. So SS to SI, we're going to match on whatever SI needs. So in this case, it will be width is D word, op n is going to be op n RM. Then op1 can be reg, and op2 can be, in this case, it's vec or memory. Then we got a prefix, so we got prefix is F3, and the opcode map is the secondary one, so map is map 0F, and then the opcode is 2D for this one, so OX2D. Then we need one for keyword, and actually this is the same thing, so I think I can just match on keyword here as well. Then we got VEX, so VEX is going to be the same. So the VEX version is also 2D, F3 0F, so, but the W is 0 for the 64-bit version, W is 1. So for this one, I think we'll need to do, yeah, so width should set W1 as well, I think, in this case. Or maybe for this case, well, I think maybe if I just control it with the W flag on the form, so I'll just split these ones out. So this one is, let's make this one D word and this one Q word. For Q word, W needs to be W1. And these need to be family is VEX. Then we've got EVEX as well, which is the same thing, but EVEX will just be used for stuff like rounding and high 16 registers. So this is EVEX. But just to make sure that I'm supporting rounding here on op2, I'll add ER, even though I can't test that right now. So that was SS to SI. SD to SI is going to probably be more of the same. So we'll just change these to SD. So SD to SI is the same, but the prefix is different. So the prefix is F2 instead. So now we're on to the truncated versions. So truncated versions are the same as the other ones, but the opcode is changing by the looks of it. So let's just copy all of these, and we'll replace all of these and just change we'll change CVT here to CVTT. The opcode for this one is to C, and then I'm guessing this one is also 2C, but the prefix is different. So we'll just change these to 2C as well. Okay, so that takes care of truncated versions. Now we've got SS to SD down here. So SS to SD is just, we've got F3, 0F5A. So I'll just do these ones manually again. So we'll do, this one is matching on X word though. So we've got width is X word. Op-N for this one is going to be op-N-RM. Op1 can be VEC, and op2 can be VEC or memory. Then we've got the prefix, which I think in this one was F3. Then we've got the map. Then we've got the opcode. And the opcode for this one is 5A. So same thing again, but for this one it's going to be family is VEX. And so we've got F30, F5A, so that's the only thing there. And then for EVEX, we need to make sure that op1 is allowing op mask. And it's allowing zeroing. And then for op3, we need op3 in these as well, actually. So op2 is just VEC, but op3 is VEC or memory. So op2 is VEC and op3 is VEC or memory. And in this case, we're also going to allow SAE. So this is F3, 0F, W0. 5A again. Oh, I've got a syntax error here somewhere. Op2, this should be op3. Okay, so SS to SD, we've got the incorrect op encoding. So these ones need to actually be RVM. Okay, and then we've got, oh, this one is the wrong one. I changed it for the wrong one. This one needs to be RVM. Okay, so now we're on to SD to SS, which is probably, I imagine, going to be more of the same again. So we've got SD to SS is the same thing, but it's a different prefix by the looks of it. And this is embedded rounding rather than SAE. So this one should be ER here. And instead of prefix F3, we've got prefix F2. F2. Oh, I need to change. I copied this. So this is SD to SS. So for this, it wants. I need to change this to F2 as well. And then this one is. So it looks the same apart from this one here. So we've got. This needs W1 set for the EVEX version. Okay, so now just SI to SS and SD. So SI to SS here. SI to SS. This is probably going to be roughly the same as these ones up here, because these ones are also SS with SI. It's just been switched around, so we'll just take these. SD, okay, yeah, so let's just take these ones. And this is SI to SS. Let's just make sure we match. Convert, okay, so this time we've got, so this time it's going to be VEC with reg or memory. SI to, do I have SI to SD? I don't. I'll have to add that in. Okay, so we've got SI to SS. This one is going from VEC and reg memory, which is correct there. This one has prefix F3, we've got OF, and then we've got 2A. So these are probably all going to be 2A. W1 is used for EVEX, and actually it's used for, W1 is used for the 64-bit ones, which is okay here. So op1, instead of being reg, for all of these should also be VEC, and this should be reg instead. Then we've got 3 operands for VEX and EVEX versions. So this one is actually going to be op2 is VEC and op3 is register or memory. So now what's incorrect here is the prefix. So this is probably because I need to do RVM, I imagine. So this is RVM. Okay, so now it's just an incorrect encoding for the EVEX version. So that looks like it may, is it not setting? So we've got SS with memory. This is for, oh, this could be because in the test, I may just need to specify that this one is D word and this one is Q word. Okay, so those pass. So now I think I'm just missing SI to SD, actually. So let's go to this test here. SI to SD doesn't exist, so I just need to copy this one. Change it to SD. And then for this one, rounding is supported except for the 32-bit version here. So let's just regenerate those. So we've got SI to SS. Just need to add a couple here for this, a couple of mnemonics. Then in form, we'll just copy the existing two SS ones and change them to SD. And then in the encoder test, I can just make a copy of these ones and change it to SD. But the 32-bit version one here doesn't have embedded rounding on it. So let's just run the tests again. Okay, so now I just need to implement the SD version, which is basically using prefix F2 by the looks of it. Okay, right, so that's scalar conversions done, and I just need to move on to the packed ones now.